Bismillahirrahmanirrahim. Dear students, welcome back. We are on online lecture number 13 of the Programming Fundamentals course. Inshallah, today we are once again going to discuss pointers in more detail in relation with arrays and dynamic objects. So, in the previous lecture, we discussed about pointers, their use, their relationship with the memory, how they are declared, how they can hold the address of another variable. But today we are going to study how pointers are related with arrays, how they are similar, and if we have time we are also going to discuss about dynamic objects. So once again, today we are going to study about pointers, memory addresses, declaration, and dereferencing a pointers to pointers. But we are also going to discuss how pointers and how pointers and arrays are similar. So with that, I'm going to jump straight to the desired slide. So uh, okay, so yes, we were on this slide, uh, and we discussed that a reference variable always refers to the same object. Assigning a reference variable with a new value actually changes the value of a referred object. So once again, a reference variable always refers to the same object. Assigning a reference variable with a new value actually changes the value of the referred object. A reference variable are commonly used for parameter passing to a function. So a reference variable is a normal variable where you store address, but changing the value of or assigning a new value to this reference variable will actually change the value of referred object. So first, if you are referring to one object, then if you change the value of address, so this variable remains same, but it will now point to another memory slot or location. So basically reference variable are commonly used for parameter passing to a function. So when you are passing some variables, some parameters, and you are calling a function, then we use these reference variable. So now we can see one of the common and traditional use of pointers. We have a main program and a user-defined function called indirect swap, where we have two uh, two pointers as a parameters, or as yes, as a parameters, and when we call them, so they are called the arguments. So we have in the main function, what we do, we have a character a having a value of y, and then we have a character b having value of n. So when we call this indirect swap function, we are calling it here, and like appending ampersand sign here means that we are now passing the address of a and b. We are not passing the value. So the address of a is stored uh, in a variable called ptr1, whereas the address of b is stored in another pointer called ptr2. So ptr1 is now pointing to uh, the value of a, or the memory slot where the value of a is stored, and ptr2 is pointing, it has the address of b, so it is pointing to the value which b is holding. So it is pointing to n, and ptr is pointing to y. Because we are swapping these contents, so what we do, we take another variable called temp, and then first we get, using the dereference operator, we get the value pointed to by ptr1. So ptr1 is pointing to y, so this value is now assigned to this value is now assigned to temp variable. So temp has now the value of y, and then we like assign ptr1 to the value pointed to by ptr2. So ptr1 now has a value. It is pointing to a value which ptr2 was pointing, and it is n. And then what we do, we get the value temp and assign it to the address which ptr2 is holding. So ptr2 is now pointing to a memory address or a memory slot, and in that memory slot you have stored the value of temp, and which is y. So now you can see ptr2 has the value of y and ptr1 has the value of n, and this is what we wanted. We our aim was to exchange the values. So ptr1 has now the value of n, ptr2 has now the value of y. Okay, so with that we have successfully exchange these values. So now if you print a will display n, and if you print b will display y, because we have changed their value by using their addresses. Their addresses were stored in ptr1 pointer and ptr2 pointer. So I hope this is clear to you. We have this traditional pointer use where the pointers were getting the address of variable a and variable b. But we have another way of indirect swap where we can call the indirect swap function, and if you write ampersand sign with this y variable and then with z operate variable, so now y and z are now able to store the address of a and b. So the address of a is now inside y, and the address of b is in z. So then you what we do, we store the value of y in temp. So temp now has the value of y. So y is pointing to the value of a, which is y. Okay, and then we are assigning the value of z, which is b, to y. So y now has the value of b, and z is now assigned the value of temp. Temp holds the variable y. So now we have successfully swapped mm, the the values inside these two variable by using pass by a reference or call by a reference. So first we uh, store the address of a and b inside y and z, and then after that we get the value of y. So y was holding the variable y, the value y. So we store it in temp variable and then assign the value of z to y. So this was like it was the value of z was in fact n. So yes, it is n, and then we assign the value of temp to z. So temp was in fact y, so z now has y. So y has n and z has y. So we have successfully swapped their values. So I'm going to run this example because it is very important to practically see what is happening at the background and how this program works. So I'm going to copy it. I'm going to start the code blocks. Okay, we have to wait, and then let me go to file, new project, console application. Okay, let me just next, and I can say it pass by reference. All right, so let me hit finish, and we have this auto generated code which we do not need. Okay, so let me go to the main slide, copy it, and I'm going to paste it here. Okay, so now if you print A and B, compile and run. So A has now n, the value of n, and you can see y, B has the value of y. So we have successfully solved these values. Right. So with that, let me go back to the main slides and let us move on. And then it is an important topic where we we have to see what is the relationship of pointers and arrays. The name of array points only to the first element, not to the whole array elements. So if you have an array A, so the name of an array is a pointer constant to its first element. So what does that mean? It means that A is holding an address, and that address is of the first element in an array, which is this A0. So A0 has an address of 1000. So A has an address which is pointing to this memory slot. And then we have address 1004, 1008, 1012, 1016. And this is the array, and these are the indices with which we can access the elements of array. Okay. Now we have another program. Array name is a pointer constant. Remember, array name is just another pointer. So if you declare an array A, and if you print address of A and use ampersand sign with A of 0, so it will print the address of the first location. But if you print just if you just write the name of array, the name of the array contain the address of the first element of array, which is in fact A of 0. So you will see it will print the same address as of address of A of 0. So these two addresses are same in hexadecimal notation. Okay, so once again, array name is a pointer constant. Array name contains the address of the first element of an array. So here we have another example. The element is called A of 0 or static A. So A of 0 contain 2, A of 1 contain 4. But if you declare this array and assign it the value 2, 4, 6, 8, 22, and then if you print static of A, so static of means A means go to the address which A is holding and print that value. So it will print the value 2. And if you write A of 0, so once again it will also print the value 2. Okay, array name as a pointers. So we already discussed that array name acts like a pointer. So array name has address of the first element of the array element. To access an array, any pointer to the first element can be used instead of the name of the array. So we could replace static P by static A. So once again, this is your program. We declared array a of 5, assign it 5 element 2 4 6 8 22, and then what we do, we like static p, we declared a pointer variable and assigned it the address of the first element of array, so array a. So now p is pointing to the first element of this array a. So if we write this statement, so a of 0 will print 2 and static p will also print 2, because both a and p are pointing to the first location of an array. Okay, we have another program where we can use multiple array pointers. So you can have array with multiple pointers. Both a and p are pointers to the same array. So this is our program. We have an array a having size of 5 and the values are 2 4 6 8 22, and then what we do, we declared another pointer and store the address of the second element, which is a of n, because array starts with the index 0. So we store the address of the second element of array, which is a of 1. So the address of this location is stored in pointer p. So if you once again see out a of 0, it will print 2, but if you print p negative 1, it will also print the value 2, because negative 1 means decrement this address by 1. So already we have p is holding a of 1, but if we write p minus 1, so it will point to the first element. But if we just print a of 1 and then p of 0, so this time a of 1 will print uh, is 4, whereas p of 0 will print 2. I think we should check this example. The code blocks. Okay, let me first copy it. Let me go back to the code block, create a new project. Once again, it's a console project, and we have pointers and arrays, and then we can go to the source code as usual. We do not need this code. Everything looks fine. Let us compile it. Okay, so we have an error. So it says main must return integer. So in main, then and the last statement will be return 0. Now let us compile it and hope that there is no error. Okay, so we have an array and the elements are 2 4 6 8 22. So first we print a of 0, which is 2, and then we print like p negative 1, again we print 2. So this 2 is like p negative 1 printed this 2, and then we print a of 1, which is 4, and then we print a of 0, and again it printed the value 4. So the question is oh yes, a p of 0, it should, I think, print 2, but let me see. P was having the address of 1, it was decremented, and then a of 1. So I think if we okay, a of 1 and then space, and then okay, let me see. If we write here p of 1. So what it will print? So far it is printing 4 and 4. A of 1, okay, I think we decremented it, so it was pointing to like 0. And now if we like once again assign it to 0, so it will print the value of 4. Okay, let me check out the slides. So we have p was holding this, and it says that p of 0 is also pointing to this value. Okay, because they are pointed to the same array. A of 0, so A of 0 will return us 2, and p minus 1 will give us 2. But if we print A of 1, which gives us 4, and then p of 0, p of 0 was having value minus 1, so it will increment itself and it will then print 4. So I think it is now clear to you. So if you have some problem, you can post it on the Google group. Okay, let me also check the time. We still have some time. So it has printed 4. Okay, let me go back to the slides. Okay, so given a pointer p plus n refers to the element that is offset from p by n position. So if we have a and p, so a is holding address of 2 and p is holding the address of 4. So what does p minus 1 means? P is referring to 2, whereas a plus 1 means a is referring to 4, a plus 2 means a is referring to 6, and so on, and then to 8, and then to 4. Okay, a of 1 printed 4, then p of 0, we came back. Okay, then p plus 1 means p is holding address of memory location where 6 is stored. Similarly, p plus 2 and p plus 3 means p is holding, it is 2 position offset from the p pointer. Well, plus 2 means that it is 2 position distance from the pointer p. Okay, dereferencing array pointers. So just as we dereference variables or pointers, we can also dereference array pointers. So just as we discussed, a is holding the address of first element, a plus means 1 means now a is holding the address of second element. Similarly, a plus 2 means it is 2 position offset from the baseline. Okay, we can use this dereferencing operator, like we can write a plus n is identical to a of n. So a of 0, you can write a of 0 or static a plus 0, a of 1 or static a plus 1. So this is how you dereference. This means that go to the address which a is holding and add that address, add one more address with that address, and whatever is stored at that location, print that value, or whatever you are doing with that value, you can do it. Okay, array of pointers and pointers to array. So we can also have array of pointers. So this is p is an array where each location is acting like a pointer. So it is this is a pointer, so it is holding address of a variable a. This location is holding address of variable b, and this location is holding address of variable c. And then we can have a pointer to an array, so we can have multiple pointers to an array. So an array of pointers can be declared as int. We assign a1 to a, b to b, 3 to c, and then we declared a pointer array which can have 5 memory slots. So in the first slot we assign the address of a, in the second slot we assign the address of b, and in the third place we assign the address of c. Similarly, we can have a pointer to an array. So this is an array list 5. It has 5 elements and we have a pointer variable. So we can directly assign list to p. Now p is pointing to the first element of the array list. But if we write ampersand sign list of 0, assign it to p, so it is same like p points to the first entry, whereas this means p points to the second entry, and list plus 1 also means p points to the second entry. Okay, we also have a null pointer. Null is a special value that indicates an empty pointer, so a pointer does not have any address. If you try to access a null pointer, you will get an error. So if we have a pointer p, we assign 0 to p, so now p becomes null because it does not have any address. So if you print p, so because the value of p is 0, so it will print 0, and if you write address of p, so it will print the address of this pointer variable. But if you write static p, so it means go to the address which p is holding and print whatever value stored. It will give you an error because p does not have any address. P has the value of 0. Okay, we can sort 2D array in 1D array using pointers variable, but I'm going to, okay, see the time. We still have 3 minutes. Okay, we have this two-dimensional array. We are going to talk more about arrays in future lectures, but here we declare two-dimensional array having 3 rows and 4 columns, 2D. The values in the first row is 0, 1, 2, 3. The second row has the value 4, 5, 6, 7, and the third row is having value of 8, 9, 10, and 11. And then we have one-dimensional array having 12 elements, because here we are having 12 elements. So we are going to sort 2D arrays. We are going to put 2D arrays in 1D array. For this we are going to use the outer loop and the inner loop, two for loops. So in the outer loop we initialized the variable I with 0, and then we test the condition I is less than 3. Yes, it is less than 3. So we move inside the nested loop where we declare another local variable j, assign it to the value 0. This condition is true, so we move to this 1. So what does that mean? I has the value of 0. So 0 static 4 plus j. So now because we have 0, so 0 multiplied by 4 is 0, and j has a value of 0. So it means at location 0 we store the value of 2D array I and j. So we store the value 0, and then we move back to this inner loop, increment the value of j. J is still less than 4 because j has the value of, now j has the value of 1. So once again we manipulate this expression. J is 1 and the rest is 0. So at location 1 we stored uh, I of 0 of 1. So 0 of 1 is this value 1. And similarly, this loop iterate for 4 times. Then when j is 4, this condition is false and we break and we go to the outer loop. Because outer loop is still running, increment the value of I becomes 1, but I is still less than 3, and once again we move inside the inner for loop, and the same is repeated. And then because I is 1 now, so 1 multiplied by 4 is 4. So at location number 4, what we are doing, j becomes, initially for the first time j is 0. So at location number 4, we are storing I is 1 here now, 1 of 0. So second row and 0 column. So at location number 4, we are storing this value 4. And then this procedure goes on, and we convert that 2D array into 1D array, or we copy the element of 2D array into 1D array. So with that, I'm going to stop here. If you have some queries or question, you can post it on the Google group. I'm going to see you in the next class. Till then, take care and Allah Hafiz.